So the first one here, when you are identifying the domain, we can find that right away. For all exponential functions, the domain is all real numbers. The horizontal asymptote, next easiest thing to do, y equals whatever the vertical shift is, which is -6. Okay, and so if I was to look at the sketch of this, I have a -6. If I wanted to test this, I can find my first point is the value of x that gives you a 0, so -1. I get 1/4 to the 0 is 1 minus 1 minus 6 gives me -7. So I know that that point's going to be -1 minus 7 below. And so right away I already know. I don't have to go any further. It doesn't really matter if my graph goes this way or this way. I don't need to know that for this. I do know that my range is going to be from -infinity all the way up to this asymptote of -6. It's never going to reach it, so it'll be a parentheses at the end of each one. Okay. In the second example, similar idea. I can find my domain easily, -infinity to infinity. I can find my horizontal asymptote, y equals, again, I look at my vertical shift, which is -5. So here's my sketch. Okay. When I plug in or plot my first point, it's the value of x that gives me a 0, so 2. So when I plug in a 2 here, I get a 0, 4 to the 0 is 1, times the negative is -1, minus 5 is -6. So once again, I get 2, -6, it falls below. And so it doesn't matter to me, or for this particular case, I don't need to find the next point. I can leave it as it is, -6. I know it's below the line, so my graph is going to be either this or this. So it's going to have a range from -infinity all the way up to this asymptote of -5, and that would be my solution.